practice question on work, energy, and power. Some practice question on work, energy, and power. Okay, first question. They said a force of 50 Newton acting on a body. Sorry for that. A force of 50 Newton acts on a body, move it 5 meters in the direction of the force. Find the work done. So we already know that in the direction of the force, that means it's a positive work. So find the force work. Solution. So we're having our work is equal to force times distance cos theta. So here our theta is equal to 0. So our cos 0 is equal to 1. So we can easily input all this into the formula. Our force, which is 50 Newton, our distance, which is 5 meters, and our cos theta, which is 0. So that's 50 times 5 times 1, and that's 250. So that means the work done here is equal to 250. So the work done here is equals to 250. Now to the second question, we have a 2 kg object is dropped from the height 10 meters. Find its velocity just before hitting the ground. So find the velocity just before hitting the ground. Use the energy formula. So here we are being asked to use the energy formula because this kind of question sometimes people may attempt it with equation of motion, probably, which may solve the question. So we have the initial potential energy mgh that is now being converted because it's staying still before falling down. So it's having a potential energy before converting it to kinetic energy. So initial potential energy is equal to mgh, converting to kinetic energy, which is 1/2 mv square. 1/2 mv square. So we now have mgh is equal to 1/2 mv square. So here we have to do some little math. So we have to make our v the subject of formula because we are looking for the velocity. So make v the subject of formula. We have mgh is equal to 1/2 mv square. The m cancel the m because they are both mass. So we have gh is equal to v square over 2. Then we cross multiply, put this one over 1. So when we cross multiply, we have v square is equal to 2gh. So from there we make our v subject of formula. We have v is equal to, we're already making that, so we want to remove the square. So we square root both sides. So we have v is equal to square root of 2gh. So now we having this formula, we can now use this formula in our equation, in our question. So we can use this formula. Now we having v is equal to square root of 2 times g, which is 9.8, times our h, which is 10. So which is equals to 198. So square root of 198, that will be equals to 14. So that means the velocity here is 14 meters per second. Okay, so it's as simple as that, using the energy formula. And if you have question on this, you can ask me in the comment section. Now to the third question, we have a car of mass 100 kg, mass 1000 kg, sorry, that moving at 20 meters per second. Find its kinetic energy. So we already know that the mass of the car is 1000 kg and is moving at 20 meters per second. So we're being asked to find the kinetic energy. So solution, the formula for kinetic energy is 1/2 mv square. So and that will be 1/2 the 1000, which is the mass, then the velocity, which is 20 squared. So we're having 0.2 is all the same as 1/2 times 1000 times 20 squared, which is 400, and we're having the answers to be 200,000 joule. So therefore the kinetic energy here is 200,000 joule. That's the kinetic energy of that car. Then to the next question, we have an electric motor lifts a 200 load. An electric motor lifts a 200 load to a height 20 meters in 10 seconds. Find the motor power. We're being asked to find the power here. So we have to find the motor power. So here, solution. We have the work done. You know, for us to find power, we have to say work done is over time. So and we need this work done first. So we have to find a way of getting the work done. So that's what we are doing here. So work done is equal to mgh, which our m is equal to 200 kilogram being given at the top, that of the load. So and we have the g, which is 9.8, and our height, which is 20. So that means we can now input this formula. So that will be 20 times 200 times 9.8 times 20, and that's giving us 39,200 joule. So that is the work done. So but we are not done because we need the power. So the power is going to be the work done over time. And the time is 10 seconds, as we have seen in the equation. So and we already gotten our work done to be 39,200. So 39,200 over 10, which is the time, we are having 3,920 watts. So the watts, the power is now 3,920. Okay, another question on this. We have a spring with a spring with a spring constant of 400. This K is spring constant. I'll say that. That's what I'm saying here. Spring constant. So it is a work, energy, and power question, but under spring. So a spring with K, which is spring constant 400 Newton per meter, compressed by X is equal to 0.1 meter. Find the spring potential energy. Solution. The spring potential energy U has the formula of 1/2 kx squared. No, the K is what? Spring constant, and the K is change in length. The change in length can be an increase in length or decrease in length. So we should know that. That's why I said change in length. So that means our U, which is a spring potential energy, is equals to 1/2 our K, that's 400, which is the spring constant. Then our X 0.1 squared. So we have our U is equal to 0.5 times 400 times 0.1, which is equals to 2 joule. So the spring potential energy is equals to what? 2 joule. Okay. So this is a formula for calculating spring potential energy. Please let's take note of this formula, which is U is equals to 1/2 kx squared, where K is the spring constant and X is equals to change in length. So, and since it is an energy, the answer will also be in joule. Okay.